Okay, now answers to some of the questions posed previously. Badly depicted exponential graph with delta x sub d here, negative delta x sub d here, the 0.01 here, and obviously then if this is a doubling displacement and the coordinate of this point is 0, 1, the coordinate of this point, the y coordinate of this point would be 1/2, the y coordinate of this point would be 2. So that this point here has what coordinates? This point here has what coordinates? If you don't remember the answer to this, or if you haven't worked it out, write it down for yourself. Think it through before you look any further. Okay, now, hopefully you've done that if necessary. The coordinates of point 1 are what? Well, the x coordinate is negative x sub d, the y coordinate is 1/2, there it is. What about this point? Well, the x coordinate is delta x sub d, the y coordinate is 2, so there's the point. So the slope of the first chord, and of course by slope 1, from what went before we mean the slope of this chord, is going to be what? It's going to be rise divided by run. The rise between this point and 0, 1 is from y equals 1/2 to y equals 1, so the rise is 1/2, and the run is delta x sub d. Well, if you divide 1/2 by delta x sub d, you get 1 over 2 delta x sub d. Slope 2, the rise between this point and this point, is from 1 to 2. 1 here, 2 here, so the rise is 1. The run is just delta x sub d. So the slope is rise over run 1 over delta x sub d. This, well, I'm not going to say. Okay, then the rise, well, I've got it written here, just what I've said. Now, that gives us the two slopes. Now, this doesn't really rise to the status of a theorem, but whatever this result is, we do have a couple of corollaries from the result. One, a little more difficult to write out than the other. First of all, what's a slope 2 over slope 1 equal? Okay, and does this depend on delta x sub d? That was the way the question was posed previously, so you should be able to work that out based on the result we have here. And then, if you double delta x sub d, by how much does that change the slope? By what factor does that change the slope? A little more subtle, because it's a little harder to actually write it out in symbols, so maybe a little more challenging. This one is very straightforward. This one is a little bit challenging, but neither one of them should be out of reach. Okay, so what's slope 2 over slope 1? Well, okay, if you haven't worked it out and you're going to watch me work it out, well, it's not the best way to learn anything, but here it is. Slope 2 over slope 1, well, slope 2 is 1 over delta x sub d. There it is. Slope 1 is 1 over 2 delta x sub d. There it is. If I were to put this over this, well, I simplify the complex fraction. It just means this divided by this. Division is the same as multiplication by the reciprocal for reasons that you should understand rather than just memorize, but that's a different story. Okay? So you get 1 over delta x sub d, and I didn't put the delta on there, and I've been leaving the deltas off here. And I kind of preach, don't do things sloppily, write things out carefully, and obviously don't always practice what I'm preaching. I need a bunch of deltas in here. So get writer's cramp writing all the deltas. I'll bet I missed one, but and if I did, yeah, I missed a couple. I missed them right here. Okay? In any case, if you take this expression times this expression, you get this over this, 2 delta x sub d over delta x sub d. And that's just 2 times delta xd over delta xd. Delta xd over delta xd is 1, so that's 2 times 1, or 2. Now, a lot of people cross things out. And then cancellation is actually a pretty valid thing, but you have to understand where it comes from and what it means. I see people canceling incorrectly all the time, so I don't like to even talk about it. What you have here is by regrouping, get delta xd over delta xd, and that gives you the identity for multiplication, which is 1, multiplied by 2 gives you 2. Okay. Second question, again, it's a little harder to write out, a little more challenging to write out. If we double delta xd, by what factors does that change the slopes? And does it always change them by the same factor no matter where you're measuring the slopes, no matter what delta x sub d is? Okay, well, slope 1 is this. Now, if we double delta x sub d, we get a new delta x sub d, which I don't want to confuse notationally with the old delta x sub d. I don't want my notation for the new one to look to be exactly the same as my notation for the old one. So I'm going to use delta x hat sub d. I'm going to put a hat on the x. Okay? And now I've got a new doubling displacement that I defined to be 2 delta x sub d, that is 2 times the original doubling displacement. So in the original doubling displacement, here's our slope. Our new slope, if we've got the new doubling displacement, double the old one, is going to be what? It's going to be 1 over 2 times the doubling displacement. But now the doubling displacement is delta x hat sub d. And delta x hat sub d is 2 delta x sub d. So we replace this by 2 delta x sub d. And simplify this, and we find that it's 1 over 4 delta x sub d. And how does that compare with this? Well, it's exactly 1/2. 1/2 of this gives you this. So that is 1/2 of the original slope 1. So slope 1 was halved. We doubled delta x sub d, that cut slope 1 in half. Okay? So that proves that doubling delta x sub d does cut the slope in half. Remember that the information put up by our student on the board indicated that that should be the case by 2 examples. Well, we've now proved it for every possible value of the doubling displacement. Okay, so we've got a kind of significant result here. It's going to be useful. Now, question, what value of delta x sub d makes the slope at 0, 1 equal to 1? Okay? There's our question. We know that there probably should be 1 because if delta x sub d is 2, the 2 chords have slopes of 1 and 2. I'm sorry. If delta x sub d is 2, the 2 chords have slopes of 1/4 and 1/2, so that the slope of the tangent line would have to be between 1/4 and 1/2, and certainly then less than 1/2. Okay? If delta x sub d equals 1/2, it turns out that the slope here is 1, the slope here is 2. We've seen that. So that the tangent line has a slope of at least 1. So that somewhere between a delta x sub d equal to 2, where the slope is no bigger than 1/2, and delta x sub d equal to 1/2, where the slope is no less than 1, we should be able to find a delta x sub d where the slope is 1. Now, whether you're going to be able to find that or not, we'll see. So, I assigned this as a group investigation, and the group spent a good amount of time trying to organize themselves to conduct an investigation that would give us a good estimate of this slope. And at this point, we have the conjecture that maybe the slope, or maybe the delta x sub d, is 2/3. Okay? Now, if I was investigating this, first thing I'd do is I'd test 2/3 very, very, very stringently to see if that could in fact be the doubling displacement. and I think I said slope, but is 2/3 the doubling displacement. I would test it very carefully to see if that doubling displacement could plausibly give us a slope of 1 at the y-intercept. And then I might, if that doesn't work, I would find another strategy for narrowing down possible values. We know again the value of delta x sub d has to be between 1/2 and 2.